Now this is problem 6.76. We know here is applied or distributed load applied to this vertical member AED. And we are looking for the X and Y components of the force which the pin A exerts on the frame, AX and AY, and also we're looking for BX and BY. First of all, we can locate the four unknowns we're looking for on this given figure. So AX, AY, and BX and BY, they are actually directly applied to this entire frame, right? It's not inside the frame anywhere. We can just take the entire frame as the system first and use the free body diagram of the entire frame. Like this. However, we have four unknowns, right? Now we have, from this free body diagram of the entire frame, we have four unknowns but three equations. So we have to reduce the number of unknowns from 4 to 3. How do we reduce that? Well, that means we probably need another free body diagram. So if we first take a look at this entire frame, well, there will be a very easy way to solve one of those unknowns. Which one? Well, which should be if you use the moment about point A. Take a look at point A. AX, AY pass through A, and also BX pass through point A as well. So that means if you use the moment about point A, you can solve the BY. Okay, BY can be solved. And next, if you use the moment about point B, same idea. BX, BY, and AX will be cancelled from this equation, so AY will be solved. Alright, so two out of 4 will be solved, and then we can only solve one more using this free body diagram. Alright, and also don't forget to replace the concentrated load or the distributed load with one concentrated load, okay, to simplify your analysis. Alright, so how do we find another free body diagram? Now here comes another important point about the frames of machines. We said a very important step when you solve a frame and machine problem is to find the two force members. Identify two force members. In this problem, we actually have two force members. One is the member CD, one is member EF. And after identifying the two force members, we can also, or it also gives us a clue which is the other free body diagram we need to draw. So we can either draw the free body diagram of the member CB or the free body diagram of the member AD. In other words, when you take away the two force members, the left members are the ones you want to choose from. Because the two force members are here to simplify the forces on the other free body diagrams. So let's see if we're going to use the member CFB, which is a member on the right, what will happen? So let's draw the free body diagram of member CFB. At pin B, that's the same support reactions we should have, BX and BY. By the way, BY is already solved from the free body diagram of the entire frame, so you can check that and put the value here directly. Then the force applied by this member EF, which is the two force member, so there's only one reaction that's along the direction of the member, so I'm just going to use EF for that. At the same time, you want to put the slope triangle on this force EF. So based on the trigonometry here, so this is 2 and this length is 1.5. So if you double each side, this will be the very familiar triangle 4, 3, 5 triangle here. So that is the EF, force exerted by member EF on the CFB. And lastly, at point C, since that's also a two force member, so there's a force CD along the member CD, which is a horizontal force. Now let's check the forces we have and the forces we don't know and the forces we want to solve. Let me change the color here. B of Y, we just said we solved it, so this one is a known value. Then we have B of X, that's 1, and E of F, that's 2, and CD, that's 3. We have 3 unknowns, isn't it? And we can solve all of them. Which one are we going to solve first? Well, probably it's not that even if we want to solve bx first, maybe it cannot be solved directly, right? But at least we know that there are 3 unknowns and we can solve all of them with the single free body diagram. So our goal is to solve B of X because we do not need a CD and EF, right? So let's solve, or you're going to solve for B of X from the free body diagram of CFB. So after we solve B of X from this free body diagram of the member CFB, then you can return back to the free body diagram of the entire frame. So this is done now, and you can write another equation to solve for the force B of, or A of X, sorry. That probably will be the equation of the Fx equals 0, right? Fx equals 0, you collect all of the F direction forces or X direction forces. One is the applied force F, and one is the Bx, and one is the Ax. You can solve for Afx. And all of those forces we are looking for are solved. Ax, Bx, Ay, and By. So you only need 2 free body diagrams to solve the 4 unknowns.